Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this Techstrong Learning experience. My name is Cody, and welcome back to Techstrong Learning. Before we dive into today's session, I have just a couple of notes to review with everyone. As always, this session is being recorded, and we will be sending it to you via email as soon as we are done with our live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, if you scroll down on the right side, you'll notice there is a Q&A panel underneath that chat section. We'd like you to submit all of your questions to that Q&A if possible. That just helps us keep track of all of the questions that we receive throughout our session. And we will be spending some time at the top of the hour to address your questions. So be sure to send those in, and we're going to take those from the top once we do open that up. Additionally, if you jump to that resources panel on the left side of your screen, you'll notice there are a couple of additional resources for you there. So feel free to grab those while you're here with us. And finally, we will select two of our most engaged attendees to win a $50 Amazon gift card. Now, in order to become eligible for this giveaway, we just need you to participate. Send in chats, send in questions, or also fill out our survey that can be found in that resources section on the left. But I'll also post a link to that in the chat toward the top of our hour. So today's topic is learn how to monitor your generative AI tech stack with Datadog. I'm joined today by Ryan McLean, Senior Technical Evangelist at Datadog. So Ryan, thank you so much for joining us today. I'm going to turn it on over to you.
Good morning or afternoon to everyone in session. We're going to be talking today about monitoring your AI stack with Datadog integrations. So if you can, maybe let me know in the chat where you're coming from or where you're dialing in from, maybe what the weather's like in your area and whether or not we think Gen AI can fix that. But I think with so much tools surrounding all of, I guess, ways of leveraging AI as a business, you might be asking yourself, like, how do I know what I actually need to inject AI use cases into my business in a profitable and scalable way? So not just do I like glom onto a buzzword and how do I integrate that into my processes, but how do I actually help my business? So in this session, what we're going to do is shift away from that theory and take a practical approach to figuring out what kind of AI tech stack setup is required to support AI workloads. And after that, we're going to learn how Datadog's AI integrations provide complete monitoring across the critical layers of this AI tech stack. Then we'll discuss how these AI integrations empower you to identify and resolve incidents, improve model performance, and strengthen the reliability of your AI systems. So what we're going to do is focus today on generative AI. So that's a category within the deep learning umbrella. It's capable of producing text, image, and content in response to a user prompt. So let's say you type in something like generate me an image of a water balloon or something like that, or on a blue sky background. You can continue iterating on it in order to give you an image that illustrates what you're looking at. So you can use these text prompts as one way of interacting with the model, but there are other ways of doing so, such as an API. So instead of having it be like a live, look at a certain amount of logs and say, hey, is there a danger going on currently? Is there like an event or something like that? Let me know if there's a bubble up trend, and then allow us to look at that trend as opposed to the process or typing things interactively. So not only can you use these models in an interactive fashion, but also as an API, I guess is what I'm trying to say. So the most common examples of these, of course, are trained models like large language models like ChatGPT. LLM are trained on massive trove of resources like articles, books, and blogs to produce human-like responses to user prompts. I know a little bit about the generative AI. I'll be honest, what I've primarily focused on in the past would be big data or data systems themselves. So how you actually get data into these areas, maybe a data lake or Databricks or Hadoop or something like that you're going to be using to train your models on. So in terms of the data wrangling, I guess that's where I come in. So I'm Ryan McLean. I'm a senior tech evangelist at Datadog. I've been with Datadog almost 4 years, and prior to that, I was an engineer at Samsung. So I've been using Datadog itself for about almost 10 years at this point in time. So since it was mainly just infrastructure, all the way to including logs and all the APM products that we've added over the years. So some of my exposure to big data and language models include using Databricks to calculate things like soil compaction risks at Caterpillar Canada, that's Finning, and sentiment analysis and recommendation engines at Samsung using Spark and Hadoop. So basically ways of us to, so at Samsung, for example, we might be looking at like a Twitter feed or the Twitter fire hose, and then trying to figure out, hey, yeah, like we just announced a bunch of new products. What does the sentiment analysis look like after that? Or it could be on a site like Finning where we're doing large digs for like the channel, for example, in the UK, and we want to make sure that the site for the next day is secure. So we're looking at sales sample models, basically going through and checking all the soil and saying, hey, is this site safe or not? And it could actually be pretty serious because the next day, if it's not safe, something could fall or trip and actually cause harm. So it's very serious, or was very serious, for us to look at these models on a daily basis. So with that experience, what I basically want to talk to you about is some of those workflows and how we can look at the way large language models or generative AI can be used in your business as a practical example. Now, I think we can all agree when I say that there is excitement around LLM tech. It's more than a passing trend. However, given how often we hear terms like AI, Gen AI, and LLM, it can feel like not using AI in your business. It might just be background noise, basically. So you hear this all the time, and it's like I think Anjali said this is it's like hearing something on Spotify a lot of times and not adding it to your playlist. So it's great tune, but if you don't take anything from it, it's kind of just noise. It doesn't really actually help you out. So integrating Gen AI and language models into your applications enabled you to build powerful tools for data analysis, intelligent search, and text and image generation, as mentioned. So there are a number of tools that you can use to leverage Gen AI and scale according to your business needs, with specialized technologies such as vector database, development platforms, and discrete GPUs being necessary to run many models. So what I'll quickly do, in case you've not heard of Datadog before, is just run over like what Datadog does and why you might want to look at us for your Gen AI needs, or if you're already a client, what we can do to provide that data to you. So Datadog is a monitoring and analytics platform that helps companies improve the observability and security of their infrastructure and applications. We like to say we solve complexity. So most importantly, we give you that end-to-end observability on a single platform powered by shared services and AI ML. From infrastructure monitoring to APM to real user monitoring, log management, security, all the way to developer experience as monitoring code not only in production but also as it's being built, we can help you get that observability. And when it comes to AI and ML, it's no different. So you're going to add the same metrics, the same logs, the same code that needs to be examined as you're writing things into production, as you start adding these pieces of technology into your running code. So before we dive into building our own LLM tech stack, I want to set the stage with some background context. So let's talk about the AI LLM model development lifecycle itself. So the cycle typically constitutes of three phases. So the explorer phase, you can investigate which ML models you might use. So it could be that for your purposes, something like Llama 2 works really well, or perhaps it's something like Claude, or maybe it's something else like you've decided to run your own little API on top of OpenAI, and it turns out that that's actually better for you. So finding those models first is that first step. So exploring which one works for you. And it could be that this is cyclical. So once you've tried something, you might want to come back to it. Say there's a new version of Cloud that goes from 2.0 to 2.1, for example, just recently, and you want to start using that within Amazon Bedrock. It might be that you want to actually go through, train your model again, and compare the two to see if it's better or worse. It could be that it's better, it could be that it's worse. So in that train phase, what you're going to do is you teach the chosen model on your training data. So when we were talking about earlier about that soil compaction rate or the Twitter fire hose, for example, or you've got maybe some PDFs within your business that you're actually updating on a regular basis, and you want to be able to interact with this data. So ask questions of some of the data that you've got. This is where you'd start training them and testing it to make sure it's actually okay. Now, in the deploy phase, what you'd run is run inference in a production environment for real use cases. So when the rubber meets the road, does this actually work? Or do we need a human in the loop to say like, hey, the soil compaction rate looks like it's drastic, but let's actually retest or let's have a look at it. Let's not just trust the model blindly. Let's make sure that we verify what's there. So trust but verify, I guess is what I'm trying to say. But Datadog's newest AI integrations are primarily focused on these deploy phases, as it's where application developers and engineers like you would run LLMs in production at scale, and it's where observability is critical to ensure high quality service to customers. Now, it's also where LLMs fit into the larger tech infrastructure of your organization. So we're going to talk about, you've probably seen these kind of hamburger diagrams before, but basically layers, a layered approach. And if you're older like me, you might think about the ISO layers or something like that in terms of like the way that you're going into your tech stack and what actually involves getting an answer back from a large language model. So we'll start at infrastructure, which I think is probably a pretty common place. We'll talk about things like storage and GPU, but we'll work our way up to that stack. So I guess what I'm trying to say here is that at the bottom is kind of that foundation. And as we go through, we're building layers on that bottom. And depending on where you are or what maturity level you're at with the large language models, it could be that you're doing all of these on your own. It could be that you've outsourced portions of this, or it could be that you're using a managed service provider that provides a lot of these. And what you're doing is building an application on top of these layers. So optimizing your system for AI often leads to upgrading your entire stack. However, doing so means reevaluating your monitoring needs as well. Otherwise, you risk adding complexity and silos to your observability strategy with the rapid introduction of new AI technology. So I'm sure if you follow the news on generative AI, things are coming out on a weekly basis. So things are changing really rapidly. The good news here is that the partners that we've gone with actually will adapt to these. The bad news for you is that you've got to start testing them. So as things change, like we were talking about the Claude models or things like OpenAI, releasing new APIs where there's new added functionality, that's going to be on you to actually test out. But what we were able to provide you is basically that observability layer already set up. So as new things are added, you're set to go with the out-of-the-box dashboard. So with our collection of AI integrations, Datadog is at the forefront of delivering end-to-end monitoring across every layer of your AI tech stack. So each integration provides an out-of-the-box dashboard with metrics tailored to critical components. So what we're going to do is explore how these integrations help you monitor each AI layer. So we talked about infrastructure. We're also going to talk about data storage and management. And we'll talk about model serving, and deployment. And we'll talk about the models themselves. And on top of this, we'll have the service chains and applications. So this might be where you come into play. So where you're adding things on top of everything, or it could be that you're primarily involved in the infrastructure layer. It kind of depends where you are in your organization with the adoption of these techs. So that foundation, as we mentioned before, of this AI stack is infrastructure in the compute layer. So in our typical tech stack, we'll have servers and data centers powered by CPUs as the underlying hardware for our entire system. However, our AI and LLM workloads require concurrent processing and complex computations being performed in parallel with speed and accuracy. The average CPU simply can't keep up, so we need to leverage GPUs, and you can access these powerhouse in the chip capabilities as physical GPUs like NVIDIA A100, Kepler, or Tesla series, or if you want, you can go through pay-as-you-go services such as CoreWeave, which we'll touch on. Now, moving up to the next layer of the stack, we arrive at data management and storage. So you've got this infrastructure, let's say you've got like a NAS or a SAN, you've got some stuff on top of that, and you're storing it, but how do you storage? How do you put it on the disk? What's actually involved in doing this? So when the rubber meets the road, what matters to you at this point in time? So you might be familiar with databases on this layer and your typical tech stack, so your state basically. But the services you'd be using in your AI tech stack look a little bit different. So AI and LLM workloads often require searching through high-dimensional, unstructured data, which doesn't conform to the use cases handled by regular tabular databases. Now, I think Postgres has been an exception here that you can add vector capabilities to it. But aside from that, vector databases like Pinecone and Weaviate transform high-dimensional, unstructured data relevant in LLM workloads into vector embeddings, and then use similarity search algorithms to query that data. So let's say that you've got two terms, for example, synonyms. You have something that's incandescent and bright, and you want to know how similar they are in terms. So what you do is you calculate that distance between them. And then what we can do is that we can use that data and we can use transfer tools such as Airbyte to securely handle that movement of vast amounts of data between your data warehouses and lakes. So when we were talking about soil compaction, for example, earlier, this data, I think we were talking about multiple tens or hundreds of terabytes. It was quite a bit of data. It was non-trivial to move it around. But a lot of the times what we actually needed was the bubble up portion. So what actually mattered was the model as opposed to the data itself. So what we'd ship around would be the model as opposed to the data because it's non-trivial. It's not one of those things where you can say, hey, I'm just going to copy this file. It's going to take a couple minutes kind of thing. It could take days or weeks to actually get things from on-prem to the cloud or vice versa or between your regions. So it's something that you really need to start thinking about as you're collecting this data. So next up the layer that we have the model serving and deployment layer. So in this layer, models are prepared for usage in a production environment. And with services like PyTorch's TorchServe or Google's Vertex AI, you can deploy a trained model for easy integration into your application and real-time predictions. But I guess the question is, what good is model deployment without models themselves? So the model layer is where the magic happens. Typically, LLM models like OpenAI's ChatGPT or Cohere are plug and play where you train them and then deploy them for your business's use case. The last layer in the AI tech stack is the orchestration framework layer, also known as the service chain layer in LLM specific stacks. In a regular tech stack, we'd often use orchestration services like Terraform, maybe, or Kubernetes to connect our application in a cohesive system that works seamlessly. Now, it's a loose analogy for what service chains do for AI applications, but the current industry standard is for service chains to be using LangChain. This may change over time, but specifically it's built to simplify the development of LLM-based applications. Whew, that was a lot. So this is what we're going to be talking about, these four layers. We're going to use those as we talk through the rest of these demos, but basically I want to introduce those so that you understood what we were talking about when we dive into each section, because we do need to categorize these. There's a lot to talk about. So to meet the needs of building, clustering, and monitoring your AI application, your infrastructure must be able to support compute-intensive workloads. So starting with our most recent agent release, Datadog integrates directly with NVIDIA's DCGM exporter to help you gather metrics from NVIDIA's discrete GPUs, which are essential to empowering the parallel computing required by many AI-enabled applications, but not alone. So we're also pleased to announce our integration with CoreWeave, which is a cloud provider that supplies infrastructure for efficiently scaling large GPU-heavy workloads. Because CoreWeave is built on Kubernetes, monitoring your Kubernetes pods and nodes in addition to your GPU is a must. The Datadog CoreWeave integration allows you to track performance and cost for your CoreWeave managed GPUs and Kubernetes resources via an out-of-the-box dashboard and pre-configured monitors. You're going to hear this a lot. Most of these will have an out-of-the-box dashboard, at the very least metrics, and I'll dive into what the docs look like in terms of what you're collecting. But it's important to note that when you start using these integrations that we're talking about, once you've got them enabled, most of the dashboards that I'm showing are enabled out of the box. It might be a little bit of configuration for logs and things like that, but they will actually show up the same way I'm showing them on screen. So what we can do is provide CPU and memory metrics for your pods with CoreWeave so you can quickly pinpoint over-provisioned resources that could bring your system to a halt. Let's say you notice a steady increase in CoreWeave usage across your pods, for example. You can pivot to the Datadog host map to then determine whether this is an isolated issue and how much of your infrastructure you might need to upgrade. Or it could be something like cyclical. So it's something that you know is going to happen on a regular basis, and it might be something that you want to automate as opposed to manually addressing it. Now, many AI models, particularly LLMs, are based on publicly available data that is both unstructured and uncategorized. So using this data as it is can be difficult for models to generate useful inferences and meaningful output. So when we're talking about the Twitter, they call it a fire hose, but basically this Twitter API, when you're grabbing all of this information, it's often difficult to tell what in all of that info is actually important to you, especially if you're doing something like, let's say, looking at NVIDIA. So you want to see what the sentiment analysis is for NVIDIA. It could be that there's things like stock analysis in there as well. So you might want to start getting rid of the things with the stocks and bull trackers. You start to develop strategies in order to whittle down the sheer amount of data that you've got into smaller chunk size. But then storing this data, you might need 2 copies or 3, depending on what you're doing, can become a non-trivial task. So most organizations will choose to use powerful yet complex vector databases to help them contextualize this information by combining it with their own enterprise data. So we talked earlier about PDS, maybe SOPs, that kind of stuff that you've got internally that you want to query as well as with its data. So Weaviate is one such open source database, giving you the ability to store, index, and scale both data objects and vector embeddings. And to access that fast setup and comprehensive support, you can also choose a fully managed option like Pinecone. So Datadog provides out-of-the-box dashboards for both Weaviate and Pinecone that give you comprehensive insights into vector database health. These integrations include standard database metrics such as request latencies, import speed, and memory usage. Kind of standard, like what's the database actually doing? But also in a vector database, you might be more concerned in things like index operation and sizes, as well as durations for object and vector batch operations. So to help you populate and manage these databases, Datadog also offers monitoring for data integration engines like Airbyte, which enable you to consolidate your data for smooth processing. Airbyte extracts information from over 300 sources and loads it into data warehouses, data lakes, and databases using pre-built connectors. With the Airbyte integration, you can analyze your data, transfer jobs, and connections to determine the health of your syncs, helping you quickly spot issues that could impact data quality. All right, so we're almost through here, the overview, but next we're going to talk about models. So that I guess the main thing that we want to talk about models is that there's a massive amount of information involved in these large language models. And because it's massive and the training is lengthy in order to develop your AI application, you need a centralized platform for designing, testing, and deploying your models. Two of the most popular AI platforms are Vertex AI from Google and Amazon SageMaker. Each comes with their own benefits. Vertex AI enables you to leverage Google's robust set of built-in data tools and warehouses, while SageMaker gives you comprehensive features to make deployments easier and more reliable, such as canary traffic shifting and serverless deployments. So let's say there's a new model. We mentioned Claude before, so 2.0 to 2.1. Maybe it's that instead of moving everything in production over from one model to another, you want to say, do a deployment that could do things like have 30% of your deployment use the new model, and then maybe 60% uses the old one, and 10 is kind of pinned to a stable version. What you can then do is sort of gather feedback from the users saying, was this response helpful or not? You've probably seen these before, but basically it can help you add weight to your confidence in the new models that you're releasing, as an example. Now, in spite of the differences, both platforms have similar monitoring needs. So to ensure that your infrastructure can support AI projects, you need to be able to track resource utilization for your training jobs in inference endpoint invocation. So basically, additionally, performance metrics are necessary for ensuring that your users experience low latency regardless of query type or size. So we're talking a little bit here about latency, and it's similar to a database, but I'm sure you've seen this before where you're typing into something like ChatGPT, and it might actually take a while. It could take up to 30 seconds. I've seen up to 45 for it to actually respond. Now, there's also a difference between the beginning of the response and the complete response. So just because it started doesn't mean you've got everything you need. It might, there could be like follow-on kind of things. So it might actually be that the latency is important, but it could be the round trip time is also important to you. So not only do I want to track how quickly I call an API, but also how long it took for it to give me the full answer. Now, with the Datadog Vertex AI and SageMaker integrations, you can access resource metrics, including CPU, GPU memory, and network usage data for all of your training and inference nodes. Plus, the Vertex AI and SageMaker out-of-the-box dashboard provide error, latency, and throughput metrics for your inference requests, so you can spot potential bottlenecks. And then, of course, in addition to deployment platforms, you can also use frameworks like PyTorch to build deep learning applications with existing libraries and easily serve your models into production. So we'll demo this dashboard a little bit. It's truncated here because it's pretty long. But basically what we can do is continuously check the health of your PyTorch models, helping you prevent faulty deployments. And with that included dashboard that we'll go over, you can access a wealth of model metrics for troubleshooting issues, including model versions, memory usage, like we mentioned, and in addition to health metrics, like ones for the torch service themselves. So like, is it up is important, but also is it serving data is also pretty important. Now, the next layer of this stack going up here is the model operations themselves. So OpenAI offers popular generative AI models that provide text and image creation, as well as APIs, I think also voice now as of recently, as well as APIs that you can use to integrate this functionality into your application. Datadog already provides an OpenAI integration that helps you monitor usage across your organization, enabling your teams to optimize resource usage and stay within budget. The latest version of the OpenAI integration comes with request and token consumption for your OpenAI account. Now, I'm saying OpenAI here, but if you're using Azure OpenAI, the same thing applies. The OpenAI integration now also supports Node.js in addition to the Python that we already supported, and you can check, similarly, your request latencies, error rates, and usage for more OpenAI API endpoints, including ones that support images, audio, and files. All right, and to complement models from open source organizations, AWS has also launched a generative AI services as part of their efforts to make AI more accessible to everyone. So Amazon Bedrock is one such service, enabling developers to build and scale generative AI applications by providing API access to LLM foundation models, such as ones from AI 21 Labs or Anthropic, Stability AI, and Amazon. And with Datadog's integration with Bedrock, you can gain visibility into Bedrock API performance and usage. All right, finally, once you identify and configure the AI models you want to choose, service chains can help you bridge together these models to create robust yet cohesive applications. So let's say instead of just calling OpenAI, you want to also be able to call Claude or call other services from Vertex AI. What you can do is set a service order, for example, in a chain. Or for example, if you've got things that are in-house as well as you're using OpenAI as an API, you can add both to your chain. So do this and then that. So once you query my PDF, then send something over to OpenAI and then come back kind of thing. So LangChain is a popular service chain framework that enables you to build machine learning models by combining easy to use modular components. The Datadog LangChain dashboard comes with visualizations for error rates, token counts, average prediction times, and request totals across all of your models, giving you deep insight into each component of your application. Additionally, it comes with a service map to help you evaluate usage across your models. So the integration supports automatic detection for a number of different models, including OpenAI, Cohere, and Hugging Face, as well as vector databases like Pinecone. So we'll drill into this one as well in the dashboard demo here coming up. But basically, there's a lot on this page. So you can see that this one is truncated as well. But further down, we can drill into them. And then finally, to help you further innovate with your AI models, you can also access tools that help you leverage them more effectively and integrate them into your existing workflow. So Amazon Code Whisperer, for example, is an AI coding companion that generates coding suggestions to increase productivity and help you easily build with unfamiliar APIs, all the way down to the CLI if you want to. If you want to add Code Whisperer to help you as you're typing in something like ZSH or Bash, you can do that as well. And with Datadog's Code Whisperer dashboard, you can track the number of users accessing your Code Whisperer instances and their overall usage over time, making it easier to manage costs. Okay, so we're going to go quickly into a demo. We had a couple chats in here, but if there's anything that you want to see demoed, or if there's anything that you're using in your environment that's particular to you, we're very interested to see how people are actually getting along with generative AI models. I realize that intro is pretty long, but basically I just want to cover what we've got in terms of the integrations before I show them off, but it's really key for us to figure out what's important to you as well. So I'm just going to go through a quick pre-recorded demo, and then I'll go through some live chat as well here. So we're just going to quickly start off with an overview of the dashboard and what it currently looks like. If you've been using Datadog for a while, you've probably seen this kind of stuff. Sorry, I'm just going to stop the video so you can see both sides here. But basically, these are kind of those overviews. So what we've done is we've taken these integrations and added them into a dashboard on its own. I'm just giving you an overview of how the dashboards work here in Datadog if you want. So for each of these that I'm clicking on, you can copy and paste them into a different dashboard if you want to. Or if you want to drill into each of these, you can hit that maximize button, which will allow you to see each one. Now, again, you've probably not seen a pie chart if you've been with Datadog for a while and haven't gone in here, but we'll talk about how to create those, as well as what's important here. So we're looking at things like temperature and power usage for GPUs, but that might be a little bit different when it comes down to something like your code or your APM. So we can do things like track seasonal anomalies. So for example, in summer, we would assume that our GPUs are a little bit higher in cost, but the other thing could be that it depends on the season for our business. So maybe during Black Friday, for example, the pricing for our models is the same, but the rate that we use the tokens with a certain model has gone up, for example, because of the big sales period and we're using sales recommendation. Now, it could be that you think that these are going up and to the right, so like a linear forecast. It could be something like a seasonal forecast. It really depends on your business, but what we allow you to do is look at these rates and then try to figure out like, hey, is this something that is like a daily concern, a weekly concern, or maybe it's quarterly or yearly? What does that look like for us? How are we actually using this product that we've got there? What does our return on investment look like? If we're using something that costs money, we're using more of it during a certain period of time, do we need to look at something like a LangChain or maybe look at something else that we can maybe stop using? So for example, in this case, we can see that on a regular basis, daily basis, it looks like it looks like things are going up to the right on a daily basis, but when we look at them like on a week period or a 2-week period, we can actually see that it's cyclical. So what I'm going to do now is quickly hop over here. My apologies. We're talking about some samples here as well. So like as you're testing these, as you're sending data to your models, what you can do is look at the responses. So if we see our prompt and then we see our output text, what we can do is test it prior to deploying a new model and then post deploying a new model to see if the answers are similar or different. and which one is better, for example. So you can actually go through and log those and then compare the two. Okay, sorry, I'm just going to quickly pause this. I'll try to pop over to a different tab here. Okay, so this is the layout tab. I'm scrolling it now. It's quite a bit bigger than you probably saw. And again, if you're newer to Datadog or you haven't used Datadog in a little bit, so when I was demoing it, it looked like this. So it's just basically increase the density for a widescreen monitor. Now, if we need to zoom in, please let me know in the chat. I'm happy to do so. But what we're going to do is talk about this diagram itself. So Angeli has put all of these together for us and giving us kind of a nice overview of all of the integrations that we've got. But there's one in here we talked about that's missing. So when we talked about PyTorch, for example, in TorchServe, it's not down here. And that's not because Angeli hasn't helped us out. It's because I haven't done the last mile. But we'll talk a little bit about what that looks like to add new components into this kind of single pane of glass, or maybe something that's comprised of little widgets that are important to you, and maybe talk about removing the ones that aren't important. So perhaps you don't manage the power, for example, for your GPUs, and you want to get rid of this one, but also this is important, the GPU temperature is important, but also you're using it OpenAI upstream, and you don't necessarily need the pricing, that kind of thing. So what does that look like once you start adding things together? So I guess the first thing I talk about is the documentation itself. And I realize this feels rudimentary, or maybe we're going back to class here, but the main thing I want to talk about is right here on the bottom of our docs. When we talk about right here, way at the bottom, after all of the configuration and all that stuff, we talked about the data collected. This is going to be key for you to look at what you're collecting per integration and what's important for these for you. Again, perhaps CPU, GPU fan speed is important to you if temperature is important, but it could be something that's a little bit different. So for example, GPU utilization is going to be pretty common, or GPU memory temperature might be important, but perhaps memory used is what you're looking at. So the reason I'm saying this is because for each of these integrations, you'll get different metrics, and we can go through the metrics explorer to find them, or you can grab them from the diagrams that are the out of the box dashboards that are already created. Again, long-winded, but just to say, like, for each of these, there's going to be an integrations dashboard that you can set up. So if you go into integrations, I'll get rid of this query. So we've got quite a few of them, a lot of integrations. I think we're over 600 at this point. But basically in here, if we want to look at the NVIDIA one, so for example, previously we might have used something like a Jetson. So you could have had it deployed on Edge, for example. It might be running something like OpenCV, so an open computer vision model. But these days, if you're actually using the DCGM version on the NVIDIA side, what you can do is start tracking like high performance clusters of GPUs together. And the reason this is important in this area is because when you go to configure the integration, this is like, once it's set up, this is where that dashboard will get locked. So once it's actually installed, and you can see that's already installed there, you will get that out of the box dashboard. And with that out of the box dashboard, you can start adding things. So we talked a little bit about the dashboard that Angeli created for us. Thanks again, Angeli. That was amazing. What we're going to do is look at this one for TorchServe by PyTorch and figure out what's important in here to us to add to our dashboard. Now, I'll admit I cheated a little bit and kind of added them here at the end, but I added all of them and I changed them a little bit just to make it a little bit more interesting. But going through here, we can say like, okay, maybe we want the logo, maybe we want some useful links, that kind of stuff. These breadcrumbs are important. And perhaps in the overview, it's important to go through here, but maybe like one or two of these are okay. So what you can do for each of these is if I click this little up arrow, if I hit copy, what I can do is actually then go to a different dashboard and then paste it in. So I'm just going to paste it here. And you'll see that it was like pasted right here. I've already got this one in. You'll see it right here in the overview. But that's how easy it is. So I'm literally just hitting Command C and Command V between tabs to copy them over. And then once we're in here, we can go through and like edit them if we want to. So for example, if we don't need this call out, you'll see that will automatically like roll up, that kind of thing. Or if we don't need this one completely, we can get rid of it, that kind of thing. So copying between dashboards is very simple. But going through here, I guess the key is, so we're looking at 1 hour for PyTorch. The key is for these metrics, what's important to us? Like what can we react to quickly? What do we need to know through here? And one of the things I noticed is when we drill down into the logs for TorchServe, for example, so I can copy this over, but it might be that not all of this information is critical for me. So for example, I see the volume by stats and I can see errors, okay, and warn, that kind of thing. And this is common, by the way, across most integrations that you'll have logs, but the key is what in the logs is important to you. It might be that it's just errors, or it could be that you need to know the volume over time. It might be that you just want the raw logs, for example, if we go into all logs here. It might be that these are what you want. You actually want to know for each of these logs what's actually going on. Or it could be that you want to start bubbling things up. So if we went into here and then started editing around, you can see kind of one of the things that I've done here for this. So what I decided was, in this case, what I really wanted to know was for those torch serve providers, which ones am I using? So the only difference here is instead of doing like a query value or a time series, which I think it was before, I've gone into pie chart. And specifically what I've done is I've kept the same source, so torch serve here. If we scroll into this one, my apologies. If we go into torch serve here, we can see that this is what we're looking at, but we're then counting it by service and cloud provider. Now, this might be important to you if you've got things in a different cloud or if a different area. For example, dev and staging might be on-prem, one might be in cloud. You're just trying out torch serve, so you've deployed it into one of your own regions, and we'll call it your private cloud. And you want to see how it's performing before pushing it up to like an AWS or a GCP. At the same time, you've already got services deployed to each of these. So what you can do is kind of compare and contrast. So which of these like tokens is being used by which of these environments, or which of these environments is producing the most logs, that kind of thing. All this to say, like once you have these raw logs, sometimes it's important to start bubbling up from the logs what's actually going on. And particularly, so we were looking at the difference in info error and rate, for example, for torch serve. Before we move it into this new graph, maybe what we want to do is actually look at these patterns instead. So instead, what we're going to do is look at torch serve and say, hey, for all these torch serve logs that we've got, can we actually give us a pattern for the past month of those logs? And maybe then we can start looking at patterns instead of the whole. So once we've got these figured out, we can then start copying them over if we want to. We can save them to a notebook. But the other thing that we can do, and perhaps we could try this in the chat and see if it works, is we can actually go and share a public URL and then start sharing it with the people. So I'm going to put this in the chat. Hopefully it works out. Maybe we can get a rise out of you. So again, click on the link, see if you can load this into your browser on your end. But what this will do is actually give you like an overview of what's going on. And if you need an export of this, just let me know. I'm sure we can help you out. But when we're looking at things from top left to bottom right, what's important to us? So is it that we want to start looking at torch serve? Is it our vector database? Which of these is important? We can start mixing and matching. But again, I want to go into some of these. So when we talk about these widgets for NVIDIA, we look at the GPU temperature, and we've got these red zones and blue zones set, but we can go through and set these on our own. So for example, if you're using a 4090 because you can't get your hands on the A series or H series, and you're doing this on-prem and you're training it, it might be that these temperatures aren't necessarily what you need on your end. So when we're looking at the event overlays or unit overrides or things like that, it might be that you want to change this a little bit to match your data. For example, on the GPUs for the 4090s, as opposed to the H or A series, it might be that the temperatures that you've got on top of this are a little bit different than what you expect. So if we say we're going to have from 0 to 30 is normal, we actually might say that we want something from like 0 to 20 is normal, depending on our temperature in our DC. And then we might actually say that we can go all the way up to 80 on our GPUs, just because we know that we've got different GPUs that can do it. What I'm trying to say here is that based on these widgets that you get out of the box, it could be that what you got is slightly different than what's in there, which is totally okay. So basically mixing and matching what's important to you is it's key here, but also setting these parameters to things that make sense to your business, as opposed to the recommendations here. So these are probably for the H series, which totally makes sense. But if you're going down to something that's a little bit more, we'll say runs a little bit hotter or is less temperature dependent, perhaps this is something you want to change. And this is key for each of those. So for each of these, let's say, for example, these average token per second, imagine if we could make this graph, instead of being sort of plain, what if we want to start adding things to it? And again, this is just visual formatting. So if we want to say something like if it's over, we're at 4.63. If we expect like a low rate to be 2, we can actually set this to 2, and then we can say something like if it's under 2, we can actually say it's yellow. So basically what I'm saying is that for this period of time, if the average token amount that we're using is less than a certain amount, It may not be an indicator that something's down, but it could be an indicator that things are being used as much as we expect. And for that, we can start adjusting these. Now, I'm doing this manually. You can also adjust them automatically as you go, or set them up as like a web call. So if you want to start updating these on a regular basis, you can do so. And again, that's for all of these. So as you're seeing these graphs come through, with like some of these are green, some of these aren't. That's how we've done this. Is actually gone through and sort of added these like lookups for you. So I'm going to quickly go through the model monitoring. So for OpenAI, for example, what you might want to know is how much am I using GPT 3.5 Turbo as opposed to 4? And the reason is that this price difference is quite a bit different. So for example, if we're looking at these token usage by model, if we're using ADA, which is quite affordable, how much is our ADA usage compared to something like our GPT-5 Turbo or something like our GPT-4? Sorry, I'm just trying to highlight these here. We got Flan, for example, we'll do Turbo and Flan. And what does that actually look like? So are we using more of the Google API calls versus the ones from OpenAI, for example, GPT-5? So basically, as you're starting to drill into these, it might be that you're actually having a business metric outcome from looking at these graphs by using different models. All right, and similarly for LangChain. So as we're going through these language requests, we can start looking at the logs completion, as well as we've got one test that's going here on Pinecone, for example, where we ask the same question over and over. So this is the response, the page content. And then if we scroll down, what we can actually look at is what is our question. So I think it was, who is Alan Turing? Who broke Enigma and who is Alan Turing are the two questions. And then what we want to do is start comparing our answers as we go along. Basically, at this point in time, we've covered quite a bit of the integrations and how they work together, how to build your own, how to copy things between them, how to share them with your team. Are there any other like things or notes or maybe like lessons learned, I guess, from building a dashboard that's this massive? Because when I look, there's got to be at least 60, 70 metrics in here. Is there like a strategy that you've got when bringing on new dashboards for people or bringing on new tech and trying to display that in a dashboard?
All right, sorry, we get cut off right at the end there. But basically, the question is in your business, when you're thinking about how you would actually monitor a business metric, the question is this a tech problem or is this more of a business problem? And where I was going with that is that often these metrics will be a little bit a portion, essentially, of something that you monitor as a business metric. So the business metric would be sales per day, or it could be amount of customers helped or clients that we led to a different decision as they were going through the checkout. That could be your business metric. Now, when you're pulling up those API calls or sending tokens to the APIs in order to get responses, those are the things that the metrics that will combine into that business metric. But if you've got other methods in which you approach this problem, I'd love to hear them. This is a fantastic problem space. Basically, when you're thinking about what makes us money or what matters to the business, the question is, how does the tech in our company actually help achieve that goal? And I think when we're thinking about shared goals or shared intents, that's really, this is sort of the, it's like the Venn diagram, basically. So this is where you've got two shared goals between both the businesses and your department, as well as your clients who want to purchase something from you all together. So it's win-win-win, which actually makes it a lot easier to measure, but getting there often requires delving into the metrics to bubble up to that business metric that you've got. Okay, I think we've got a couple questions in here. I answered one. All right.
Yeah, it looks like we've got one here from Amit Kumar. Does Watchdog integrate with these metrics and logs to build enhanced insights beyond dashboards?
Yeah, so the short answer is it depends. In general, though, yes. So basically what Watchdog will do is actually look at your trends and let you know if there's something like an outlier or something that's a little bit different than the norm. And I think as we go along into these metrics, we'll get more permeated, I guess, with the Watchdog and what it's actually working with. But the quick answer here is like yes. The long answer is as we add features, it can be a little bit of like a trailing metric, that kind of thing. But the answer is yes. So Watchdog, the whole goal is to have it watch the metrics as they come in, and then give you insight in terms of maybe what normal looks like or what a trend looks like, especially if you're looking at like a seasonal abnormality. For example, if you've got a really high sales period. I know Black Friday, for example, in North America is quite high. It could be Singles Day in Asia Pacific, that kind of thing. But if you've got a seasonal change, I think that's really where this actually comes in handy. Now, that being said, if you've got it assigned to something like a dev environment, it may be that you're getting not false positives, but in terms of the trends or outliers, it might be a little bit different than what you're looking at. So I would say generally what you want to be looking at is staging and prod for this kind of thing, but the answer is yes here.
Perfect. Thank you, Ryan. It looks like we've got a few more questions here in our queue. Can you track error rates on models built using OpenAI?
Yeah. So maybe we'll unpack this a little bit. So if you've got like an OpenAI model serves, you certainly can. So I guess what I'm trying to say here is if you ask a question and the answer that you got back is different than what you expected, that may be an error to us. This is more about that business metric kind of thing. So if I ask it, why is the sky blue? And it gives me an answer that maybe isn't necessarily correct, that could be an error for us, but not necessarily an error from the API. That being said, when we're calling the API, those 4 golden signals are still very important. So we've got latency, errors, traffic, and saturation. So in this case, what we're actually looking at are the errors. So if I send a request to that API and I get back something that's either like a 400 code, say 401, 403, what have you, or a 500, meaning like there's an error with the service, those are certainly errors, and we can let you know if they are increasing or decreasing, or day over day, what that looks like, week over week, that kind of thing. Definitely. Now, hidden in this question is if we're building models on OpenAI. So just to uncouple that a little bit. So it could be that what you're doing is taking models and modifying them. I would say though that the ones from OpenAI are probably not the ones that you're going to be using when you're modifying models or training. It's probably going to be something more in the open source space. Now, the providers that we talked about do allow you to use some of these open source models in their stack. So for example, you might have something like Llama 3 or Mixtral, like a mixture of experts model, where you may be sort of adding things to it. I think these days, however, the workflow seems to be more around RAG. So that's retrieval augmented generation. So it's more like when we were talking about those PDFs earlier and LangChain. So if we want to add a store of data and then use the language model to actually look up something in a vector database, figure out if there's an embedding that matches, and then give us the data. So I was talking about the sky blue, but if I want to know what kind of shade the sky is, whether or not it's Azure, I hate to make a Microsoft pun, or something like a corporate blue, or how close the sky's color today is to the Datadog blue, those kind of things would be like us uploading a marketing template and some hex codes, maybe a palette of the colors that we're using. So we're adding data to it in order to give us a little bit of an indicator in terms of what the answer, like the Datadog answer or the corporate answer might be, as opposed to the model's default answer. Now, this is something where we're not necessarily maybe building a model or training a model, but augmenting the model. So if that's something that you want to do with one of those OpenAI models, absolutely. Now, when it comes to error rates from those, absolutely, you'll have an API that's serving the AI model for you. But again, the errors, quote unquote, here, or the misses, if it's missed a document, may be something that you have to measure on your own actually when evaluating the models. And this is why you end up with those logs that we had, like asking about Turing and Enigma and things like that. Because what you want to do is basically ask the same question and get a similar result from the end. And what I've noticed in terms of a pattern is perhaps you're asking this on a regular basis from something like an API, but maybe on the back end, what you're using is something like a private model to actually allow you to rate what's coming through. So you're using it both on the front end to do sort of a sanity check to make sure that when I move from version 1 to version 1.1 or 1.2, that the results didn't necessarily get too skewed or too far from the truth, while at the same time giving us answers. And maybe it's something that you're working on for speed. So when we talked about end-to-end latency, maybe what you're trying to do with the model is have something more lightweight that gives you back an answer faster, which is great, as well as maybe you're trying to figure out accuracy. So in terms of the latency, we can certainly track that. The errors, we can say, hey, it's a 400 or 500, but the quality generally is something that you may actually want to have a multi-step process in. So you could do something like, what do we call it? That virtuous development cycle, where you deploy a model, run a test automatically, have that test be evaluated automatically and then graph that on a chart. I think that's kind of where we're going at this point in time, where we're doing actual training as opposed to like a RAG a stack. But it looks like, and again, this is emergent, so things change every week as mentioned, but it looks like at this point in time, a lot of people are going down maybe more the RAG path as opposed to the retraining or pre-training path in order to add that little bit of fine-tuning on top, because fine-tuning can be expensive, which is what I think the actual question is when we're fine-tuning, can we check to see if the answer has sort of strayed a little bit further from the truth than we wanted.
Awesome, Ryan. Thank you for all of that, for that question. I know you dove in and really gave us all the answers and pulled a couple questions out of that as well. We do still have a few more questions here that are related to what you just discussed. Does Datadog monitor OpenAI models other than ChatGPT?
Yeah, so I think in this case, I want to say it's either, I think it's Ava, for example, is the text embedding one. We talked about different versions of ChatGPT as well. So you might have ChatGPT 3.5 or 4. I should know this. I believe 4.0 is also in there, but basically what we're tracking is the endpoint that you're using. So imagine that you're hitting an API endpoint that has a model on it. We can tell how many calls you're hitting essentially. And if we've got something like instrumented JavaScript or Python code, then we can actually say, hey, when you're making this call, what is the endpoint you're hitting? And then again, give us those golden signals for the ones that you're tracking. I will pull it up here, but I believe those are the ones. I don't want to say it's exhaustive, but I think it is. Now, I did share a link out to the dashboard that we were talking about in the chat as well. So what I'm doing is basically just going through that just to make sure that it's in there. But I believe, so at the very least, we've got the ChatGPT models. All I'm doing right now is making sure that we actually check a GPT-4. So we've got, so there's DaVinci, Babbage, 3.5 Turbo, and 4 in here, at least in terms of the demos that I was looking at.
Very nice. Yeah, I know there have been a couple new models that have been released since 4.0.
Indeed, it's hard to stay on top of it all.
Oh, absolutely. So it looks like we are at our final question for today. They just say we covered a lot, but what is the easiest way to get started with generative AI?
Right. Okay. So this is a really big space. And I think the main thing that I covered in the beginning is like having a business problem, right? So having a reason to go down this path that makes sense to the business. So that shared concern, that shared goal, that kind of thing, be it sales or what have you. If you've got a goal in mind to use something like this, and I'm not saying it's required, but basically when you have that goal, I think it's a lot easier to figure out what success looks like or what good looks like in the end. So if you've got your outcome in mind, I would say, having delved a little bit in this, the wizards, I know this, but generally we give a side eye to the wizards, but I would say, for example, AI Studio in Azure is quite easy to start working with. There's a playground in GCP as well that I thought was quite good. And then on the Amazon SageMaker and Bedrock side, I actually had a pretty good time with those. But all this to say is that I feel like on-prem, if you were to start maybe down this path, it might require some investment into hardware, essentially, which can be a barrier to entry. So for example, if you don't have the latest and greatest NVIDIA GPU, it doesn't mean that you can't do this. It might be that the results that you're getting are slower than you expect, unfortunately. That being said, there are models that are smaller now, small enough that you can run on a Raspberry Pi, but depending on what you're putting into them, it may be that you're going to be, again, dissatisfied with the results that you've got. But I think on the cloud side, it actually makes it pretty easy not only to get started with a model and start asking it, your business questions, or even start adding those RAG stack application, basically that the info in on the side in order to ask of it data before you get back an answer. I think that's kind of the happy path right now. And those 3 cloud providers that I've used, there are others, my apologies, but those quick starts on something like a hosted solution seem to be the easy way where you can turn something on, test it, and most importantly, turn it off. And I say this because some of these, when we're talking about the tokens, some of these token payloads, when you're sending them to an API, especially if you're going down the retrieval augmented generation side, can be quite large. And the tokens add up really quickly, and the API costs add up really quickly. So I would say having your goal in mind and your outcome in mind before you start with some of these wizards with the clouds would probably be the easiest way to get it. And then you're scratching that itch. So you get the virtuous cycle of trying something, getting feedback quickly, and not spending too much money if you've got like a budget around it, while at the same time getting results back that show you what the realm of the possible is without necessarily leaving it on all the time or signing up for a contract that locks you in. Again, I totally understand each of these cloud vendors will have differences and different models that they align to. So for example, if you're more interested in cloud models, you may want to go to the Amazon side of things. OpenAI and Microsoft have a pretty good integration. And on the Google side, if maybe you want to go down the open source stuff, or maybe use Google's Gemini models, these are good ways to test them. As a Canadian, for example, it was a little bit difficult for us to get access to Claude prior to being using in Amazon, and I think as of April it's now open up, but it depends on your region as well. So it may be that different models are available to you in different regions. The cloud providers can help you there in order to give you like a managed service that you can use.
Awesome. Well, Ryan, we know how to get started now, but before we do take things on home, I do just want to ask you if you had any parting words, any key takeaways, or final thoughts before we do shut things down.
I guess, as usual with emerging technology, it might seem that there's a lot changing, a lot happening, and that's certainly true. But I would say the sooner you get started with this, the sooner you'll be able to decipher what's going on. And listen, that I said a lot during this webinar, there's a lot going on, and it changes a lot too. But keeping abreast of the trend, I think sooner rather than later is going to set you up for success.
All right, well, Ryan, before we do close things out, we got one last question in, so let's squeeze it in. Can Datadog monitor AI models for data poisoning attacks?
Okay, so this is like a feature that we've got in public beta at this point in time, but we do have something called LLM observability. I think we've got a link in the handouts that I'd recommend looking at, but we monitor 4 things. One of them is poisoning. And for those of you who've not heard of this before, imagine that the AI prompt. So if I'm the API and you're asking me a question, generally you have something like, you are a helpful AI assistant. Please answer all questions to the greatest of your ability, that kind of thing. So that is my system prompt. So when a question comes to me, say from Cody, types in something to a chat, and I'm the chatbot and I answer, I would have that in mind, or I'd preface the answer with that in mind. And I'm personifying here, which is dangerous with LLMs and generative AI models. But what the way to poison a model would be something like, allow it to give you the answer that's maybe not helpful, or perhaps maybe unsafe, or we could say uncouth, or maybe like without empathy, that kind of thing, without compassion, that kind of stuff, without morals or ethics, what have you. Because most of these models that are published have those in mind. They don't want to give you the wrong answer, for example, or give you, if you're looking at a recipe, give you something that's not related to the recipe. Now, one way to poison them, unfortunately, is to add things like logic problems at the end. There are a lot of them, like plus, and, equals, bracket, 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 square bracket, that kind of stuff that you add to the end of it that can essentially escape or jailbreak out of it, or poison the query. Now, what you want to do is look for these strings, but also look where things are maybe completely off topic. Now, there's ways of hardening this in that system prompt, but as you get there, it's important to watch these because, again, with emerging technology, the attacks will be emergent as well. So they'll change on a regular basis. So on our end, within LLM observability, we do have one metric that will allow you to watch for the poison queries, essentially, but there are others as well. So for example, we talked about non-answers. We talked about the poisoning. But there are other metrics in there that basically you want to watch for. So let's say you had a plan to deploy a Gen AI model. You've deployed it, and now it's out there in the wild and people are using it. You will notice that there are things that people will do to your model that are perhaps orthogonal to what you're talking about. So maybe not completely unrelated, but if you're in Datadog asking one of our chatbots or whatever about metrics, and then you decide to ask it for a recipe for pizza, that might be something completely unrelated. We may actually answer you as well because we hadn't thought of somebody asking for a pizza recipe. So it might be something that we need to track going forward. Now, for us, what we do is actually check, hey, is this like on topic, unrelated, that kind of stuff. And it might be that you fix in your model. It might be that you track bad behavior in your clients as well, and don't necessarily change something on your back end, but maybe change the behavior in terms of who you block or rate limit or what have you on the front end.
Awesome. Well, Ryan, we are at the end of our hour. To our audience, just a couple of final things. There is that survey that I posted in the chat. It's pinned at the top. You'll also find it in the resources section on the left side of your screen. If you wouldn't mind clicking that survey and letting us know your feedback from today's session, Your input goes a long way, and we love to hear from you about what we bring to you. So please do fill that out for us and let us know. That will also make you eligible for our $50 Amazon gift card. So thank you so much for your chats and questions today as well. Now, today's session was recorded, and we will be sending it to you via email here shortly. So just hold tight, and you should get that in your email inbox before too much longer. Ryan, thank you so much for joining us today. The past hour has absolutely flown by, and I really appreciate you staying on and fielding all of our questions. So thank you so much for being here with us.
Of course, and thank you for hosting us.
Happy to. So to everyone here, thank you so much for joining us. We appreciate you spending your time here with us at Techstrong Learning, and we hope to see you at a future learning experience. Have a great rest of your day, everyone, and you may now disconnect.